Alrighty, in this video we're going to be talking about why are two triangles similar. So we've talked about why are triangles congruent, and we've used theorems such as side, 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 side angle, side, so on and so forth. Alright, but what about similarity? And similarity, remember, works a little differently than congruency because they are the same shape, but they can be different sizes. Alright, they can be an enlargement or a reduction, a blow up or a shrink. Okay, so the first similarity is angle-angle similarity. And if we have two angles of one triangle that are congruent to two angles of another triangle, that's enough to show that the two triangles are similar. Okay, and you might be asking yourself, why don't I need to show all three angles? Well, remember, if you show two angles are congruent, you automatically know the third angles are congruent. Okay, that third angle theorem of triangles. All right, so if we can show two angles of one triangle are congruent, that's enough. All right, so the easiest way for me to think about that is if you have an equilateral triangle where all the angles are 60, could be something small like that, or it could be something really big like this. These are both equilateral triangles. They are definitely not congruent. All right, but their angles are congruent. Their angles are congruent. The figures themselves are just similar. Okay? So, in example 1, let's see. Do we have enough to prove that the triangles are similar? If they are, write a similarity statement. So, well, we've got vertical angles here. Angle SVR is congruent to UVT. Got vertical angles. And we've got parallel lines here. So, if I were to extend these parallel lines and extend these transversals, then you would see that angle S is congruent to angle U. All right? Or the other parallel lines here, cut by this transversal, you could see that alternate interior angles, angle T, are congruent to angle R. So, again, we don't need to show all three of those angles. 2 would have been enough. But just showing you how we can prove all those angles congruent. We've got vertical angles, and because of those parallel lines cut by a transversal, we have alternate interior angles. So do we have enough here? Yes, we do. So triangle, the left-hand triangle, I'm going to say SVR. That's just the order I'm going to choose. And that's going to dictate, so similar to triangle, that's going to dictate the order of my next one. Since I started with S, I got to start with U. And then I go to V, which matches up with V. And then it goes down to R, which matches up to T. So the order there is important. It has to look like this. Triangle SVR is similar to triangle UVT. Since I started with SVR, to match up the corresponding parts, my second triangle had to be UVT. All right? What about in the second one? So we've got a 90-degree angle, which matches up. And we have a 68-degree angle and a 22-degree angle. So at first glance, you might be like, well, no, these are not similar. I don't have two angles that match up. But let's figure out what are the third angles in each of these triangles. So if I take 90 plus 68 and I take that away from 180, this angle right here is 22 degrees. Boom, that's enough. We've got congruent angles here. All right, we got a 90-degree angle that matches up and the 22-degree angle matches up. So if I start with triangle, if I say ABC is similar to triangle, and since I started with A, I got to start with D. B matches up with E, and then C matches up with F. So yes, on both of these. So I've got angle-angle similarity on both of these. Okay? So that's the first similarity theorem to prove that triangles are similar. All right? What about side-side-side similarity? Okay, now if you remember, for similar figures, the angles were congruent, but the sides were proportional. So if the corresponding side lengths of two triangles are proportional, then the two triangles are similar. So if we can set something up so that like AB over RS equals AC over RT, which equals BC over ST, if all of those ratios equal each other, that's enough to prove that the two triangles are similar. All right? And something that's going to help us set up these proportions right here so that you make sure you're setting up the right ratios. The shortest side of one triangle matches with the shortest side of the other. Medium to medium, large to large. Okay? So, is triangle GHJ similar to triangle ABC? Well, we need to make sure our ratios match up. Okay? So, the shortest side in triangle GHJ is 16, which matches up with 8, the shortest side in triangle ABC. 16 divided by 8 is equal to 2. All right? So, 16 matched up with 8. Now the medium side. 18 is going to match up with 9, which simplifies to 2. And then the largest side, 24, matches up with 12. 24 divided by 12 is 2. So 2, 2, 2. All of these proportions simplify to give you the same thing. So are these two triangles similar? Yes, by side, side, side similarity. Side, 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 and then just the similar symbol after that. Okay? What about in part B? Are these triangles similar? If so, write a similarity statement. Okay. So in this one, match up small to small, medium to medium, large to large. So small is going to be 6 inches over 4.5 inches. I'm just going to use my calculator, and I'm going to see what these simplify to give me. This is 1.3 repeating. All right, medium is going to be 9 inches to 6.75 inches. So 9 divided by 6.75. That also gives me 1.3 repeating. So it seems like we're doing all right so far, but we have to check the final one. Large to large, so 12 over 9. 12 over 9, which simplifies to give me 1.3 repeating. So they all match. So I can set up a similarity statement. If I'm doing triangle ABC, okay, is similar to triangle. Now, I'm going to say A to B is 6, B to C is 12, and A to C is 9. I know it doesn't say what specifically the side lengths are, but I'm going to, for our sake, do it that way. So AB is 6, BC is 12, AC is 9. Therefore, in the second triangle, XY is 9, YZ is 6.75, and XZ is 4.5. All right, so AB, which was 6, matched up with 4.5, which is going to be XZ. And then BC, which is 12, matched up with... Okay, actually, without us knowing what the side lengths are, scratch everything that I just said. Let's scratch out this part. We're going to need to know. We can't just make up what the side lengths are. So are the triangles similar? Yes. By side, side, side similarity. Okay? So sorry for that hiccup there. But without knowing the specific side lengths, we can't make a similarity statement. All right, and the last theorem is side angle side similarity. So if an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides that include those angles are proportional, then the triangles are similar. Okay? So, like for example, in this diagram to the left, I'm telling you that angle X is congruent to angle M. Therefore, we would need to show that XZ over MP equals XY over MN. It needs to go side, angle, side. It needs to be that order. So side matching up with this side. These angles are congruent. And then the side matching up with that side. Needs to go in that order. Okay? So, now that we've got all the different similarity theorems, angle, angle, side, 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 and side, angle, side, let's determine if the triangles are similar. Okay, so in example A, we've got this top triangle, and sometimes I find it helpful just to draw them separately. 4, 5, and then this is V, W, X. And we've got the big triangle, which is V, Y, Z. And VY, I need to add those two together. That's going to give me 12. VZ, add those two together. That's going to give me 15. All right. Well, hopefully you notice that they share angle V. So we've got an angle that's congruent. Now we need to check the corresponding sides. So 4 over 12, that's going to simplify to give me 1/3. And 5 over 15 is equal to 1/3. So their sides are in proportion. The angle in between the two sides is congruent. Therefore, yes, these are similar because of side, angle, side. Side, angle, side. Okay? In part B, again, if I draw this small triangle separately, I've got P, T, Q, 4, 5, and 6. For the big triangle, which is P, R, S, I've got PR is 8, PS is 13, RS is going to be 10. All right, so these two triangles share angle P. They share angle P. So we've got a congruent angle. Let's check the sides. Small to small, we've got 4 over 8, which is 1/2. Medium to medium, we have 5 over 10, which is 1/2. Large to large, we have 6 over 13, which does not equal 1/2. So this one throws it off. So the fact that not all my sides are proportional, these are not similar triangles. Okay? We were close, but it wasn't enough because when I matched up small to small, medium to medium, and large to large, not all of those proportions were equal to each other. Okay? Let's knock out letter C. Well, hopefully you see these two triangles. I have vertical angles there. So I've got a congruent angle. All right. I don't have any parallel lines here. So we got to check the sides. Small to small. So 3.5 to 7. That's going to simplify to 1/2. So 3.5 to 7. That matched up. And 4 over 8 simplifies to 1/2. So these two sides, oops, that's a bad. These two sides also match up. So yes, because it goes side, then angle, then side. Okay? So there we go. How to interpret these diagrams. Look for a shared angle or congruent angles, and then check small to small, medium to medium, large to large, to see if you have enough to prove that the triangles are similar using one of those three theorems. All right, let's do 2 final application problems, then we'll wrap up this video. So find the value of x that makes these two triangles similar using this similarity statement. All right, so let's match up corresponding parts in a ratio. So AB, x minus 3, is going to match up with DE, which is 20. AB matches up with DE. And then that's going to equal, since I started with x minus 3 on top, I need to start with 10 on top here from the first triangle. And AC matches up with DF, which is 2x plus 3. All right. So we've got our proportion. Now we just need to cross multiply and solve. So we got 20 times 10, which is 200, equals, and then here we got to be careful. This is a big quiz test question because of this step right here. We need to take all of x minus 3 times all of 2x plus 3. Okay? We need to make sure we put those in parentheses because when I multiply them together, I need to remember to double distribute. All right, so I've got 200 equals x, so this again, x times 2x, which is 2x squared, x times 3, which is 3x, negative 3 times 2x, which is negative 6x, and then negative 3 times 3, which is negative 9. Okay? Combine like terms, so I'm going to get 200 equals 2x squared minus 3x minus 9. I need to set this equal to 0, so I'm going to go up here to finish this problem. So I get 2x squared minus 3x minus 209 equals 0. Okay, so from here, this sure looks like a tough one to factor. We'll see if it is factorable, but we're just going to use the quadratic formula. So x equals negative b, so negative 3, plus or minus the square root of b squared minus 4ac. Okay, so negative 3 in parentheses squared minus 4 times 2 times negative 209 all over 2a, so 2 times 2. All right, so my numerator simplifies to 3 plus or minus, and then inside those parentheses, or underneath that square root, that's going to simplify to give me 1,681 all over 4. Okay, so what is the square root of 1,681? Is that a nice number? Yes, it is. So x equals 3 plus or minus 41 over 4. So if I simplify this then, 3 plus 41 is 44. 44 divided by 4. So x could equal 11. Or x could equal 3 minus 41 divided by 4, which is negative 9.5. All right, x equals negative 9.5 doesn't work because that's going to make my side lengths negative. X equals 11 does work. So x is going to equal 11 there. All right, this right here is a big quiz or test question. Make sure you know how to double distribute correctly, multiply those two binomials together in order to get the correct quadratic. All right, and then last problem, why are the two triangles similar? Well, they share an angle up top. And because I have two parallel lines here being cut by this transversal, I've got these congruent angles here because of corresponding angles. All right, so I've got angle-angle similarity because of a shared angle and because of corresponding angles. All right, so now that we know that these two triangles are similar, we can set up a proportion. So if I draw these triangles separately, we've got 8 and x for the top smaller triangle. And for the bigger triangle, we've got 12 and x plus 6, right? This is going to be 12. This is going to be x plus 6. So if I set up my proportion, 8 over 12 equals x over x plus 6. Oops. So we got, if we cross multiply, we got 8 times x plus 6 equals 12 times x. So 8x plus 48 equals 12x. 48 equals 4x, so x equals 12. Okay? So, a lot of practice problems there, a lot of different diagrams, but the main idea are these three theorems to prove triangles are similar. Angle-angle similarity, side-side-side similarity, or side-angle-side similarity. The angles are congruent, the sides are proportional. All right? Make sure you check out the practice problems, try those out. Let me know if you have any questions. Have a good one.